Stats Medic, does type of SAT matter? So go ahead and turn to the next page here in your packet and go ahead and do the does type of SAT prep matter. Come back and then I will give you the answer. So please pause it so you can get the most out of this. All right, so now that you have finished it, it first of all says outline a completely randomized design to compare two treatments. Guys, there's always a lot of different ways to do this. I tried to choose the simplest. It said since there was 50 students, the 50 students, those ways to get the 50 students, I could do that a random, I could do stratified, I could do cluster, or I could just ask for 50 volunteers. With an experiment, you don't have to have a random selection to get the students. You have to have a random assignment to assign them into their groups. Because sometimes we need volunteers, because if I'm specifically studying diabetes, I have to get people with diabetes to be part of my study. So I can't just randomly choose people from the population. So I have to have people with a specific condition. So this is the main thing for you to see, is that the big thing here for experiments is I have to have random assignment. When I'm doing surveys and when I'm doing observational studies, I am doing a random selection of my actual group. So remember, a random selection is how I choose. It's choosing my group randomly. And I have to do that when I'm doing observational studies or surveys. With experiments, it's not necessary, because what I'm having is random is the assignment of treatment. And this random assignment of treatment is absolutely 100% necessary. Okay, so you're gonna put them, randomly assign them. Again, try to make them roughly equivalent. It doesn't have to be exact. But if I had 50 students and I knew I had, let's say, 30 males and 30 females, and I was wanting to block them, then of course, or excuse me, 30 males and 20 females, then of course that's not going to be equivalent. But if I'm just mixing them, I do them as equivalent as possible. And then group 1 would get the online prep course and group 2 would get the teacher prep course, and then I would compare the SAT scores. Okay, so let's change this now to a block design. So a block design is if I'm just saying, okay, I think that seniors and juniors, that it might be a difference. And so again, look at here, that seniors and juniors, I have 30 juniors and I have 20 seniors. And so I would place them into the two groups. Clearly this is not random because I'm placing them into those groups. However, your random assignment then comes next. If you would notice from here, I would do group 1 would get my online course, and then group 2 would get my teacher prep course, and I'd be comparing only those seniors that took the online versus the teacher prep. Then if you'd notice here, the juniors got the exact same treatments. I did it exactly the same way. And so I'm comparing seniors to seniors and juniors to juniors because I'm thinking that possibly grade could greatly affect, which means it has a confounding effect on the outcome. So I'm going to want to compare them separately. And then of course, once I have the results, I combine and compare them. The next one, this is called a matched pair. Now remember yesterday when I talked about matched pair can be if I have two people that have some very similar quality that I'm going to be doing, or yourself. Now, I can't pair yourself to yourself on this one because if I compare you taking the course and you not taking the course and vice versa, it's going to be a lot harder to do so, because if I have you take the SAT without the SAT prep course and then take the SAT prep course and then you have the SAT test, you have the confounding variable with that you already took it once. And you have to do a random assignment, and if I already took it, the SAT prep course, and I took it, then I can't untake it. So I'm going to have to do some sort of matching. So this is how I decide to match them. You might have another great way that works. I'm going to put the 30 juniors in order from highest to lowest GPA. And so I'm going to group them 2 at a time. That's the main thing, guys. You got to have 2 at a time with the highest GPA and pair them. So you could make a little design like this in the same aspect. But then once I've got them paired, then here comes the randomization. You have to do some sort of randomization. Flip a coin, INT, random number digits, roll a dice. But flip a coin to assign 1 to an online class and 1 to the teacher class. Then you're going to repeat the process with the next 2 highest until all 30 juniors are assigned. So I have 15 pairs of students, 15 matched pairs of students. Okay, the things that I'm reminding you that you did take notes on yesterday, but to remind you here, is that first of all, you have block. Block is when you have a group of experimental units that are similar and look like block here. Remember what I did was I had 20 seniors and I had 30 juniors, and I'm placing them into blocks. And the whole idea of blocks is that because I think that there's a grade is greatly affecting them, I'm going to separate them by grade to try to reduce the confounding variables in my actual results. A randomized block design is where I separate the subjects into blocks and then I randomly assign the treatments within each block. The matched pair is just a block of size 2. And so a block of size 2 is just subjects are paired and then randomly assigned to treatment. Each subjects receive 2 treatments in order of the treatments. Now block is just like stratified is to surveys as and observational studies, as block is to experiments. So blocking and stratifying is the same exact thing. However, stratified refers to surveys and blocks refer to experiments. All right, and that's it for here. If you could take 5 minutes and do checking for understanding, please pause so you can get the most out of it. All right, hopefully you paused it, and now here you go. I'm going to go ahead and do the answers. Number 1 is a completely randomized design. So to compare this, you have 300 subjects. You have a random assignment because it's completely randomized. So I have 3 ads, so I'm going to group 1, group 2, group 3, and then add 1, add 2, add 3, and compare effectiveness. Now a randomized block, remember, let's put them in blocks. So we're going to say, okay, go ahead and figure out what sort of block you think would make sense. You could do male, female, athlete, non-athlete. What I had decided to do is I said, you know what, I think that older people and younger people are going to watch different things or be I guess affected by advertisements differently. Okay, you could say males and females could be affected differently. You could say athletes and non-athletes or musicians and non-musicians. However you decide to block it, just say whatever your thing is. The whole idea is you have to have a reason for the blocking, and the blocking is the whole purpose of blocking is because you're reducing a sort of confounding variable. And this confounding variable was that you feel that older and younger people are influenced by different types of advertisements. So remember, within each block, and I write the word block here, by the way, so I'm showing I'm blocking. I'm random assignment, group 1, 2, 3. And so if you notice this here, look guys, this is identical. From here, this is identical. All those 3 are identical. And that's it. And the whole randomized block design, why is it more preferable? Well, the block design helps control age as a confounding variable. Within each block, there will be lower variability of results, making it easier to determine which ad is most effective.